Good morning, welcome to my question of the day, and this is number 18 in a series that I've been running throughout September. So the question that I've chosen today from the UKMT Senior Maths Challenge is the following. I've got positive numbers x and y. Ooh, x is greater than 0 and y is greater than 0. Do you know what? I always write something like that down just to remind myself. They satisfy the equations which are below. I've got to find the value of y. Okay, now when I look at that first equation, I think to myself, I can see the difference of two squares hidden in there. I really like the difference of two squares. If I start by not using that pen, if I start by writing down x to the power of 4 subtract y to the power of 4 is equal to 2009, I notice that x to the power of 4 is just x squared, and y to the power of 4 is y squared as well. That tells me it's the difference of two squares, if you hadn't noticed that already. So I would write x squared, yes, add y squared, multiplied by x squared, subtract y squared, because that's how to write the difference of two squares in a factorised form. If you've never really seen that before, if you multiply out my pair of brackets now, you will get x to the power of 4 subtract y to the power of 4. It's just practice that I can look at that and do it. Now, I'm also told in the question that x squared add y squared is 49, and I can see that x squared add y squared is now a factor in this expression, in this equation I should say. So I'm going to write down that since x squared add y squared is equal to 49, that must imply that 49 lots of x squared subtract y squared is 2009. And if that's true, then x squared minus y squared is going to be 2009 divided by 49. Now, I don't know about you, but my 49 times table is not very good. But I've just got a hunch that maybe I could divide both of these numbers by 7. So I'm just going to try and do that just over at the side here. I've got 2009 divided by 7. 7 goes into 20 twice, which is 14, remainder 6. And 7 eighths of 56, which gives me a remainder of 4. And lo and behold, 2009 was divisible by 7. So I should have 287. 49 divided by 7 is also 7. Now, I've just got a hunch that I think 287 can divide by 7. And if I divide 287 by 7, 7 into 28 goes 4, and 7 goes into 7 once. Ah, yes. I have actually got the answer, 41 over 1, which is, of course, 41. Now that means I've got another relationship. I now know that x squared subtract y squared is 41, and I also know that x squared add y squared is 49. I can spot a pair of simultaneous equations now, and I'm going to subtract these. I'm going to end up with 2y squared is 8, which implies that y squared must be 4. Well, if y squared is 4, then y has to be plus or minus 2, or positive or negative 2, I should say. But, however, I know in the question that I had positive numbers for x and y, and therefore there is only one answer. Y has to be 2. If I look up to the question, the answer was indeed B. I hope that helped you. If you want to leave a comment below the video on YouTube, please feel free. If you'd like to visit my Facebook page and leave a comment, or just to find out my other questions of the day, it'd be great to have you there. And please send in your answers. It's really lovely to see work solutions. Make a maths teacher very, very happy by sending photos of your work solutions. Okay, that's all for now. Thanks very much. Bye-bye.